So in this video, let's practice the first example of solving for the missing lengths in the right triangle using the method that I usually prefer. And I want to review that method again. And we are using the trigonometric functions first, which is sine for S, and cosine data for C, and the tangent data for T. And let me do it cosine first. And for cosine, it starts from the h, and it goes all the way down to the x, which is the adjacent side of the data. We need to remember that the we use c always. We also need to write it near data always. And the starting line, which is h in this case, should be the denominator, and this ending line, which is x, should be the numerator. So if I write it down, so cosine theta should be equal to the h, which is denominator, and in the numerator x. And let's do the sine. And for the sine, we are using s for the initial value, and it also starts from h, and it goes all the way up, and it goes down to the y direction. And we also need to remember that sine data should be equal to the starting point with starting line, which is h in the denominator, and in the numerator the ending line, which is y. And let's do the tangent data. And for tangent data, it starts from this line right over here, which is the adjacent side of the data, and it goes all the way up, and it goes all the way down again. And this is the way how I write tangent the t for initial value of tangents, and it starts from x, which means the denominator, which is x, and numerator should be y. So this is the way how we did it. And let's apply this method into this example right over here. And we know that this angle right over here is 40 degrees, which means our central angle is 40 degrees. And they gave us the length of hypotenuse, which is 5, and they asked us to find the length of BC. And let's apply cosine first. So I'll write cosine data, sine data, and then tangent data. Let's apply cosine data first. So from this central angle, we are writing C for the initial value of cosine all the way down the AC, and that is that should be AC, which is the denominator, and the numerator or AB, and the numerator AC. But they gave us the value of AB, which is our hypotenuse, but they didn't ask us to find the length of AC, so that means cosine data is not the solution for this question. What about the tangent data? For tangent data, we write from the adjacent side of the length of the angle, and it goes all the way up, and it goes down again. Well, it includes the side that we want to find, but it doesn't include the another side that should be given. So that means tangent is not also the solution for this. And what about the sine? For sine, it starts from the hypotenuse, and it goes all the way down. Well, it should be the sine right over here. It should be the starting line, which is 5. Numerator, the ending line, which is BC. And it also gave us the missing, it includes missing lengths and also the given lengths. That means we can solve it, and that means sine data is our solution. So if you were to make the equation for this missing lengths, we can do that the sine of central angle, which is 40, should be equal to opposite side, which is the given angle. I'll just call it x, over the adjacent hypotenuse, which is 5. And we can multiply 5 to the both sides in order to isolate x, and the 5 will cancel out, and then 5 times sine of 40 is equal to x. So in this video, we have practiced this example 1, and using the method that I usually prefer, and the answer was the sine was the solution for this question. In the next video, I'm going to use let's practice the second example of sine and cosine and tangents examples.